Hi everyone, this is Dr. R. Chitra, Professor from the Department of Information Technology at K.S.Rangasamy College of Technology, going to give a short lecture about computer organization and its architecture. So, what are all the functional units in a computer? So, a computer consists of input, memory, arithmetic and logic unit, and output and control units. The input unit is responsible for gathering the information from the user, and whatever the data that is being gathered are being loaded at some storage, that may be a permanent storage. So that is called as a memory. And you have an arithmetic logic unit which is responsible for performing the arithmetic operations such as addition, subtractions, and logical operations such as and or. And output unit is responsible for representing that logical operations or arithmetic operations results over to an output device. So that is responsible of an output unit. So that output unit can be a monitor or it can be any sort of display units. And you have a control unit. So that control unit will be responsible for controlling various operations of this function unit. So the input unit accepts the coded information from the human computers using the devices such as keyboards or from other computers over digital communication lines. The information is stored in the computer's memory either for the later use or to be processed immediately. So the processing steps to be accessed from that is in whatever the data available or to the memory can be fetched, that can be represented in a sequential steps. The results are sent back to the output unit, and these are in turn is controlled by means of a control unit. If you see the basic functional unit, you have a memory. So that memory is being interconnected between the input, output and the processor. So the input and the output unit will be responsible for gathering the input from the user, and after processing the data, they are displaying the output to the user through this output unit. Apart from that, you have a processor component consisting of arithmetic logical unit and a control unit. Arithmetic unit is responsible for responding the arithmetic operations, and whatever the data that you need to fetch or store it into the memory is handled by the control unit. So these in turn, the memory, processor and the IO devices are interconnected by means of an interconnection system. So a program is a list of instructions which performs a basic task. So normally these programs are stored in the memory. The processor fetches these programs from the memory, and it will be forwarded to the units for performing that appropriate functionalities. The data are represented in terms of numbers and characters that are used as an operands. Instructions and the data are handled by the computer must be encoded into a suitable format. So the hardware at the present day uses a certain digital circuits which uses the stable states. Instructions, numbers and the characters are being processed by the processor, and they are being forwarded to the output unit. And the computer accepts the coded information through the input units, and the common input device is the keyboard. Touch, mouse, joysticks and trackball are the examples of input unit. Microphone can be used to capture the computer audio, and cameras can be used to capture the image, system images or any object images. And coming to this memory unit, the function of the memory unit is to store the program and the data. There are two classes of storage called binary and the secondary. Primary memory, also called main memory, is a fast memory that operates at the electronic speed. So the program must be stored in the memory when it is being executed. So a memory consists of a large number of semiconductor storage cells, each capable of storing 1 bit of information. They are handled in a group of fixed size called words. Memory is organized so that one word can be stored or retrieved in one basic operation. The number of bits in each word is referred as the length of the computer. Typically, it is of 16-bit, 32-bit, or of 64 bits. So, to provide easy access to any word in the memory, a distinct address is associated with each word location. Addresses are consecutive numbers starting from 0 that identify successive locations. A particular word is accessed by specifying the address and issuing a control command, and the memory starts that the storage or the retrieval process. So, the storage or the retrieval process over a memory is initiated by the control unit. Instructions and the data can be written into or read from the memory under the control of the processor. Memory in which any location can be accessed in a short and a fixed amount of time after specifying an address is called as a memory access time. The time required to access one word is called as a memory access time. This time is independent of the location of the word. Typically, it is represented in terms of nanoseconds or under a smaller and a faster RAM unit called a cache. Cache is tightly coupled with the processor and is usually contained on the same in the integrated circuit chip. Purpose of the cache is to facilitate high instruction execution rates, repeated access rates, and the instructions stored in the cache in order to fetch it at a faster manner. Primary memory is essential. It tends to be expensive and does not retain the information when power is turned off. Less expensive, permanent secondary storage for large amount of data and program that are accessed infrequently. Magnetic disk, optical disk, and flash memory devices are some examples of secondary storage devices. Arithmetic logical unit performs arithmetic logical operations, and it is initiated by bringing the required operands into the processor, where the operation is being performed by means of an arithmetic logical unit. So when the operands are brought into the processor, they are stored in high-speed storage elements called registers. Each register can store one word of data. Access times to registers are even shorter than access time to the cache unit. Output unit is the counterpart of the input unit. Its function is to send the processed results to the outside world. A familiar example of such device is a printer. So printer operation are coordinated by the control unit. So control circuits are responsible for generating the timing signals that govern the transfer and determine when an action is to be takes place. Data transfer between the processor and the memory are also managed by the control unit with the use of a timing signals. The computer accepts the information in the form of programs and the data through an input unit and stores it in memory. Information stored in the memory is switched under the program control into an arithmetic and logical unit where it is processed. Processed information leaves the computer through an output unit. All activities in the computer are directed by means of a control unit. Individual instructions are brought from the memory into the processor which executes the specified operations. Data to be used as instruction operands are also stored in the memory. For example, load R2 LOC. This instruction reads the contents of the location whose address is represented symbolically by the label LOC and loads it into the processor RC. Loads by the processor to the register R2. First, the instruction is fetched from the memory into the processor. Next, the operand to be performed is determined by the control unit. Operand at LOC is switched from the memory into the processor. After the operands have been loaded from the memory into the processor registers, arithmetic and logical operations can be performed. For example, add R4, R2 and R3. So here the contents of R2, R3 registers are added and loaded into the registers R4. Here the operation performed is the summation of the values available in the registers. So after completing the desired operation, the results are in the processor registers. They can be transferred to the memory using the instructions such as store R4 LOC. This instruction copies the operands in the registers R4 to the memory location LOC. The original contents at the location LOC are being overwritten here. So a processor, if you look into that with the interconnection, so you have a main memory and a processor memory interface might be there. So which will be consisting of which will be acting as an interface for connecting this program counter, instruction registers, and a different set of control registers starting from R0 to Rn-1 and followed by a number of arithmetic logical unit and a control unit. The instruction register holds instruction that is currently being executed. So its output is available to the control unit, which generates the timing signals to fetch an instructions or the data which are being associated with it for execution. The program counter is another register and it contains the address of the next instruction that is to be executed. So whenever a program is being fetched or an instruction is being fetched from the memory, the program counter value is being incremented. General purpose registers are there, so which are normally represented with R0 to Rn-1. And a variety of functions including holding the operands have been loaded from the memory, and these registers are helping it for storing that intermediate values. So processor memory interface is a circuitry which manages the transfer of data between the memory and the processor. If a word is to be read from the memory, the interface sends the address of the word to the memory along with the read control signals. And the interface waits until the data is being ready, then the data is being written over to the memory, then the interface transfers the address to where the data is to be written or to the memory along with the data. Next one is the normal interrupt. Normal execution of the program may be preempted if some device requires urgent in-service. In order to respond immediately, execution of the current program must be suspended. To cause this, the device raises an interrupt signal which requests for the service by the processor. Now the processor will stop the executing of the current instruction and supports the execution of the requested set of operations. The memory locations and addresses. Memory consists of number of registers, each capable of storing a value of 0 or 1. Group of n bit is referred to as a word, and you will be calling it as a collection of n word, you will be calling it as a word length. So memory locations. Coming to this memory locations, to store or retrieve any sort of data, in order to access it, you need to have an address. So normally the address will be taken from 0 to 2k-1. So the memory can have up to 2k address. The 2k address constitutes, this 2k address will be calling it as an address space. So you can have a signed storage, or you are using it, you will be representing from B0 to B31. You will be representing it to B32 bit, and if the B31 bit is being set to a value 0, then it represents a positive, otherwise it is a negative number. So for representing characters, we'll be using a 32 bit, and each character is being represented by an 8 bits. And so consecutive 32 bits represented by forms a character representation here. So then name Big-Endian is used when lower order addresses are used for more significant bytes, and the Little-Endian is used for the opposite of ordering, where the lower order bytes are used for the less significant bytes. So if the lower order bytes is used for more significant, that is Big-Endian. Lower order byte is used for the lower representation, then it is called as a Little-Endian. So if we come into this figure, so if we are using this lower order bytes for more significant bits, then it is a Big-Endian notation. And lower order bytes for lower set of bits, then it is called as a Little-Endian representation of a memory. So this is how we are going to represent the data over to a memory. And next one is that